And tonight's presentation is called Diet and Greenhouse Gas Emissions. And it's by Leslie Duram, Dr. Duram. She's a professor, Fulbright Scholar, and director of the Environmental Studies program at Southern Illinois University. She's also the author of many books and publications, primarily on environmental issues. She's a well-known speaker and has received many prestigious awards and is a plant-based vegan educator through the Physicians Committee on Responsible Medicine, PCRM. Dr. Duram's research interests are environmental, geographically, local to global scale environmental issues, local food systems, environmental public participation, climate change activism, and campus sustainability. She is also the editor of Sustainability, special issue, Local to Global Scale Environmental Issues. If you've gotten the newsletter, you'll have a link there that you can go and follow up and learn a little bit more about her and her work. So let me just turn it over to Leslie. We're very thankful that you're here. And my wife says, you got to get her on. You got to get her on our presentation. So we've done that. So I feel good about that. Anyway, here she is, Leslie Duram.
Okay. Thank you very much for the kind introduction. Oh, hi. I'll go ahead and share my screen. And again, it's a very, it's sort of this odd echo, I can't see all of you, but I'm hoping you can see and hear me. And then in the chat, you can ask questions. Like I said, I'll stop about halfway through and see if there are questions. And then again, of course, at the end, we can chat. I will make note, I was mentioning earlier to John, so I'm Central Time, thank goodness not Eastern, but Central Time. So I'm 2 hours later than you, and it's getting to be almost bedtime. So I hope I'm awake and aware enough to answer questions and so on, but I'll do my best. So I'll go ahead and share the screen now and just make sure that you all can see me and see this. John, can you see that?
I can see it. Yep.
And now it's full screen, it's okay?
Full screen, yep.
Okay, very good. Okay, so yeah, I'm going to talk about diet and greenhouse gas emissions. This really brings together two key themes in my research and my personal interests. So I'm at Southern Illinois University at Carbondale. The easiest way to get to my website is just right there, ess.siu.edu/Duram. But I'm sure John can tell you also if you want to get in touch with me or have any questions, but Southern Illinois University. Okay, so we're going to start off with some climate science here. And the key thing you need to think about is that our climate here on Earth, the stability of our climate on Earth really depends on energy coming in and energy going out. Okay, so we have solar energy, light coming in, reaching the surface of the Earth, and then we have terrestrial energy or heat that's leaving the system all the time. And this is great. This is how it's supposed to be. The problem is that these are impacted, especially more recently here, by human or anthropogenic factors. The climate system is not just like we think. I think we sort of always think, oh, it's temperature and precipitation, but there's actually 5 parts to the climate system, and it's really, really cool because they all interact. So we have the atmosphere, of course. We also have the cryosphere, so all the ice on the planet. We have the oceans, we have land surfaces, and we have vegetation, and all of those things matter. All of those things react with each other, interact with each other, and then act as this whole amazing system. So now, we're going to kind of go into this link of the bigger issue here of climate change. And we talk about the greenhouse effect, and that's a good thing. I always like to stress that. The greenhouse effect is good because if you look here on the right, Venus doesn't have enough, it has too much of a greenhouse effect, right? It's too much of a blanket, so it's too hot. Mars doesn't have enough of the greenhouse effect, not enough of this atmosphere, so it's too cold, but the Earth is just right. So the way that works, if you look on the left, is the normal greenhouse effect. We have CO2 and especially methane and nitrous oxides, and they act as this wonderful blanket, right? So we have the solar radiation coming in, we have just enough heat escaping and going back. The other kind of bounces around, stays on the Earth's surface, or it stays within our atmosphere, and it keeps it just right. Not too cold like Mars, not too hot like Venus. But the problem is that humans have messed with this greenhouse effect. And so we now have an enhanced greenhouse effect with increased levels of nitrogen, of CO2, methane, and nitrous oxides. And what's really crazy is then that acts as a bigger blanket, right? So we're not re-radiating enough. We're keeping too much of that heat here on Earth. These greenhouse gases, you'll see that GHG, greenhouse gases, are only 0.04% of the atmosphere. Mostly it's nitrogen, argon, oxygen, and so on. But just that little 0.04 needs to be nicely in balance. And it has for most of human history. But unfortunately, now we're messing around with that. So if we have actually pretty good data through ice cores, through various different methods and means, looking back, and here, if you look on this chart, across the bottom is 10,000 years before present. That's, on the x-axis there, the horizontal line. And the purple, you can see those various amounts, those various numbers, temperatures right there, or I'm sorry, CO2, so carbon dioxide concentrations in the atmosphere. You can see it's kind of pretty stable, 250 up to maybe, 275 right in there. And then when we pull that out into that little pop out graph there from 1800 to present, you can see how rapidly we've increased the CO2 concentrations in our atmosphere. And that's related, of course, to the Industrial Revolution. We get, there's climate deniers who like to say, oh, this is just a natural process, it varies. Well, again, looking back at that, you can see that doesn't look anything natural because this is all related to human activities. But another way I like to talk about this is, when people say, oh, it's just natural, and climate scientists say no, because this chart here shows it so well. If you look at the graph on the bottom, we know, right, we have data that show from 1880 through 2020, what are the forces that affect global temperature? Well, you see the one red line, that's solar variation, right? People say, oh, it's solar flares or whatever. Volcanic activities, when a volcano goes out, you have all that particulate matter in the air, in the atmosphere, and that actually cools the planet to some extent. Well, that's the dark blue line there, right? Where it goes down a little bit. But the natural variability, what we know about natural factors affecting global temperatures, that's all right there in that green line. And that's pretty darn close. I mean, there are little blips there, but it stays pretty close to the 0 degrees Fahrenheit, right? So it's pretty stable. But we know actually the top chart, the red line, those are actual observed temperatures. Those are real temperatures that we have on the planet. And you can see how greatly, you can see that increase. Well, the only way to describe that, to explain that, is to include the human causes, the human factors in the climate system. So the release of these greenhouse gases, this increasing concentration of greenhouse gases due to anthropogenic human emissions. So climate modeling is super cool and amazing and really complicated, but this simple chart sort of shows everything you need to consider. So first we have this amazing, wonderful, huge planet, and then we're dividing that into little bits, right? So a grid, pixels, if you will, to talk about different places. But not only that, then you need to also think about each of the physical processes, everything from the depths of the ocean to the high, atmosphere. So not only are we dealing with a place north, south, east, west, but we're dealing with depths to heights across the planet. But we use things like atmosphere, ocean, general circulation models, and those are three-dimensional numerical models of the climate system. So there's some really cool, smart people out there doing this modeling, trying to keep track of all this stuff. And they develop things like this, and then we can sort of project forward. So here, the top map shows projected change in temperature by 2090 if CO2 emissions drop to 0. So if we take strong, decisive action as humans now, and we can drop our CO2 emissions by 2080 that's the inherent heating that we will still get. So if you look at the chart there at the bottom, we're at like 2 degrees, 1.8 Fahrenheit, 2 degrees, 2.5 degrees Celsius, I'm sorry, Fahrenheit is on the right in that top map. So that would be like a best case scenario. We come together as humanity and take actions to reduce our greenhouse gas emissions. On the other hand, if we opt for the bottom map version, that's where CO2 emissions are triple by 2080, which if you looked at that previous, one of those early graphs, that's actually kind of possible given, what humans are doing right now. And those are really, well, I'll just say as a scientist, those are pretty scary looking maps. So we're talking up to, on the poles, it could be like 11 degrees Fahrenheit difference in terms of mean annual temperatures. So Fahrenheit, right? That's a lot. 10 degrees, 11 degrees difference. Those are really scary looking models, but that's how we're able to now model through all of these various, computer simulations. So then we can actually talk about what we know and what we're projecting forward. And on this chart, you see the gray line from 1950 to 2000. Those are temperatures we know. This is how it looked. And then we can project forward the temperatures with various scenarios. So again, IPCC, I'll get to that in a minute, the various international community, various international scientific organizations come together, and that top line would be a really high-end scenario if we just continue to do as we are doing with emissions in terms of industry, transportation, food choices, everything else, that we could easily be increasing up to 4 degrees Celsius, which was what, over 8 degrees Fahrenheit. Or best case scenario, it's more in that purple range where we still increase, but it's not quite as, well, deadly. But those are the kinds of projections we do with all of this mapping and so on. You may have noticed I've been using info from the IPCC, which is the Intergovernmental Panel on Climate Change. It's fascinating. If you don't know it, I highly recommend just Google it, ipcc.ch. It's the international organization that was created in the late 1980s. And it's the World Meteorological Organization plus the United Nations Environmental Program. They actually won the Nobel Peace Prize, the IPCC won in 2007. And it's sponsored through the UN, and 195, basically every country in the world is a member. And the IPCC makes reports that then each country uses to inform their own policies. So thousands of scientists work on these reports, and they assess the science of climate change. They summarize all the various research that's been done, and then they kind of make these reports on different, land issues, sea issues, climate, policy issues, human issues, food issues, all these sorts of things. And they talk about the drivers, what's causing climate change, the impacts for all of us, the risks to different people in different areas, mitigation, so what we can do to act now so it doesn't happen, and then adaptation, what we will have to do to survive when it does happen. It's an open review process. Again, check out that website, nothing secret there. You can read all of the reports. There's a lot of information from IPCC. So there's like thousands of charts, but these are the kinds of things that you can pull out of that. And the reason I like these is it describes, so the top one is land surface air temperatures. This is 1850 to 2010. And the top one is actually 4 different data sets, right? So it's land surface air temperatures, and those 4 different colors are on that chart, but they are in pretty close agreement, right? So one is probably from China, one is maybe from Europe, and one is the US, and one is Australia or whatever, but 4 different data sets or 4 different universities, wherever that data is from, they are all in agreement or very similar, right? The middle one is sea level rise, and again, 6 different data sets are showing very similar trends, right? Some are Arctic sea ice extent, 6 data sets, you can see how rapidly Arctic sea ice is melting. So IPCC is able to take information from all over the world, pull all these scientists together, and publish these reports. So IPCC recently said, people are, well, how do we know this? Well, evidence for a warming world comes from multiple independent climate indicators, from high up in the atmosphere to the depths of the oceans. And I just think that sentence kind of says it all. And this chart likewise. So we see the down arrow, meaning less glacier volume, less snow cover, and less sea ice area. And then we have the up arrow on everything else. So air temperature, water vapor, marine temperature, sea surface temperature, ocean heat content, sea level rise, overland temperature, and so on. So IPCC is bringing in, and we have data points on all of these. What is it? 2, 4, 6, 8, 10 different data points there. And then we're, they've modeled this across the planet. So a lot of data, a lot of information. Actually, that's where I was going to stop and see if people had questions. I don't know if I can pop out and see the chat. John, do you see anything?
There's no questions at this moment. I think everybody's just absorbing and learning.
Maybe I'm overwhelming. Sorry. This is me right before bedtime. Just imagine me on coffee. Okay, so the IPCC then has all of these various ways that we're talking about climate and so on. And so I thought some of these statements were really useful. So this is from their 2018 report. The top one, warming of the climate system is unequivocal. Since the 1950s, many of the observed changes are unprecedented over decades to millennia. And then the second one, the atmospheric concentrations of carbon dioxide, methane, and nitrous oxides have increased to levels unprecedented in at least the last 800,000 years. And that asterisk is important because that brings us to the topic of food. So a quarter-pound hamburger requires about 460 gallons of water. That's a whole other issue that we could all talk about, water and water issues across the planet. But in addition, it takes about 64.5 square feet of land. But then it gives back methane, which is extremely potent, a very potent greenhouse gas, and about 4 pounds of greenhouse gas emissions combined. So that asterisk then I wanted to mention, because you'll see reports like this. These greenhouse gas emissions are often given as CO2e, which means CO2 equivalent. So what it's doing is it's taking the nitrous oxides, the carbon dioxide, and the methane and putting that all together to figure as one number. So we're not reporting it as 3 different numbers. They're all variously, important. And you can see the nitrous oxides are mostly from the manure and the fertilizer. Methane is mostly from the ruminants and manure and so on, and then CO2 from the various fossil fuels. But we pull all those together and talk about CO2e. This graph here then is from the journal Science, and it's showing that they're kind of estimating how your diet impacts those GHGs. So that up the side there, if you look on the left side, food-related GHG emissions in CO2e, gigatons of CO2e. And they're estimating that in 2005, red meat is, of course, a significant part of those greenhouse gas emissions. Then on top of that, poultry, eggs, and dairy. So basically, if you took out light blue, yellow, light green, red, that's your meat eaters, your food, your dairy and meat sort of contribution there. So if you just do the staples, so orange, dark blue, and gray, that would be from there on up, which would be a vegetarian, vegan diet. And that looks pretty bad, but then when you project it forward, because they're estimating, well, and I mean, they're advertising, they want people, right? The meat industry wants more people to eat more meat so they can make more money. And so when you increase that, that even looks worse, right? So when you have more red meat, more poultry being consumed, then that's gonna push those greenhouse gas emissions even higher, as we look towards the future. So again, the IPCC has even started coming out with some statements about food. It's sort of interesting. It's like, yeah, why didn't they do this sooner? I've been wondering. But people have always been hesitant. I think we blame a lot on transportation systems, and we haven't always thought about the impact of food. And so I'm happy that we're at least talking about it. But a lot of people are still, trying to deny this. But in any case, they say things like, avoiding meat and dairy is the single biggest way to reduce your impact on Earth. That's a pretty strong statement. Meat and dairy provide just 18% of calories and 37% of protein, but take up 83% of our farmland. And finally, impacts from the lowest impact animal products typically exceed those of vegetable substitutes, providing new evidence in the support of dietary change. And again, that's an IPCC special report from 2019. So fun facts, the top right one is the nation of cow, or I guess I call it the Republic of Cow. So if cattle were a country on its own, they would rank third in greenhouse gas emissions. You see China there, then the United States, and the Republic of Cattle is very, very close. So just think about that magnitude, right? On the left, for 1 year, if everyone in the US ate no meat or cheese just 1 day a week, it would be like taking 7.6 million cars off the road. And then another comparison just with methane would be that 1 cow is equal to about 80 cars on the road. So again, we always talk about transportation, but we need to think about our food consumption. So let's think about that food consumption. So we live in an industrial agricultural society, so that the goal is the profit for the shareholders. And so just like tennis shoes, you got hamburgers, right? So what's the goal of a shareholder? They want the lowest possible input costs, right? They want cheap inputs and high output so they get more profit. So the fossil fuels are going in, the GMO seeds, the fertilizers, the insecticides, they want that as cheap as possible so that they can produce the highest possible meat and dairy so that they can sell that and make profit. That's purely it. I mean, they're not concerned about human health. They're not concerned about helping the world. They're not, I mean, it's an industrial system that's built on profit, not on health. And so what we have then are CAFOs, and that's concentrated animal feeding operations. These are defined by the US EPA as operations that have over 1,000 head of cattle, or over 2,500 pigs, or over 125,000 chickens. And I've looked into this so very often, and I've looked everywhere, and you see different reports. Basically, the upshot is we don't really know how many there are. There's something like 20,000 CAFOs, but there's no comprehensive database that actually shows where they all are and how many there are, because they all go back kind of to state departments and sometimes even county departments of health and so on. So it's just incredible to me that there is no, I mean, you let me know, email me if you found a comprehensive database on this from the EPA, but I have never been able to find it. But we're estimating about 20,000 in the US. These operations actually use about 80% of all antibiotics that we use in this country. Why? Because they just give it, you have to give, well, these people give the antibiotics to the animals just automatically. They don't wait for any of them to get sick, because they're all so packed in together. By the time one got sick, all 125,000 chickens would be sick, right? So they're just automatically given antibiotics from day one all the time in their feed. In a scenario like this, kind of backing out, thinking about the environment, right? The environment is just another input. It's just like fossil fuels. It's just like seed. It's just like fertilizers. They're just simply being held in our environment, our earth here, but it's really about the profit. So what are some of the impacts of this then? Well, I've mentioned water use. Think about, there are issues with clean and safe water across the planet, but we're using so much of it in this animal feeding system. That also is related to water pollution. So where we have these heavy areas that's showing the dead zone down there off of Louisiana, because so many agrochemical runoff comes off down through the Mississippi and then causing the dead zone of hypoxia down in the Gulf. Also, this is related to land use and deforestation. And these examples on the bottom right are former rainforest in Brazil. We're rapidly still, even now, rapidly taking down rainforests, which are, basically the lungs of the planet, right? They're a huge carbon sink, tearing those down even now to plant soybeans and corn. And likewise, then we have soil degradation, because these areas aren't meant to be used heavily for crop production. We have climate change, as I've mentioned. So these are some of the environmental and ecological impacts of meat eating. Okay, so let's kind of start pulling this back towards people and climate a bit more. But basically, right now, globally, meat consumption is about 92 pounds of meat per person per year. In the US, 268 pounds of meat per person per year. We're one of the highest in the world. I think Brazil and at some point Argentina and Australia was higher than us. We're all right in there. We're close. So part of this issue is this system has been built up over time because the US has the system of policies and subsidies of commodity crops. So commodity crops include corn, soybeans, wheat, cotton, and so on. And so they're overproduced in these countries because up to we subsidize these to something like $25 billion a year so that the agrochemical corporations can buy those crops super cheap. And then we have this overabundance of feed, which we can then feed to these animals so that it keeps the price of beef and dairy and all of that artificially low. So they have cheap livestock feed, we have cheap corn so that we have high fructose corn syrup. It also goes into ethanol. So there are lots of sort of subsidies of all of these things that we don't even really think about. In addition to that, which you might want to consider that a bit unethical already with subsidies, but also I'll talk about two other issues of ethics. One is simply the idea that billions, with a B, billions of land animals are killed each year. Add to that all of the sea life. It's an incredible number, an incredible amount of life that is killed each year. So that's a second ethical issue. Another ethical issue would be the sort of in and out, right? So only 55% of calories produced globally actually go to food for people. The remainder go to biofuel and livestock. So let's talk about, this is how they like to talk about, if you look at the livestock magazines, conversion efficiencies. So that is calories of feed in to calories of food produced. So in and out, right? So the conversion efficiencies for dairy are about 17%. So number of calories in, you get 17% back, right? Eggs, 17% calories in, calories out. Poultry is 13, pork is 9, and beef is by far the lowest. So the conversion efficiency is only 3% with beef. And the chart here, it's a little hard to see maybe, but that kind of shows it. So it's showing all of the calories going in, whether it's pasture or concentrates or roughage or hay or soybean, corn, whatever. And then you can see on the right, the pink is pork and poultry and eggs. Dairy, beef is the red, which has the huge, the significant red arrow is the loss there, right? So we're going, and it just displays exactly that conversion efficiency. Well, conversion inefficiency, I suppose, would be a better way to think of that. So ethically then, it would be easier to feed the planet if more of the crops we grew ended up in human stomachs. So the green on this map shows food for humans. So where do we grow food for people? And the purple shows food that's grown for food and for feed, so livestock feed and fuel, so biofuels. At this current time, or in 2020 at least, the FAO and UNICEF reported that 823 million people are chronically undernourished. Well, you can imagine that if we were growing more food for people, we could possibly reduce that number of people who are chronically undernourished. So people really need to know this, and yet it doesn't appear anywhere, right? There's no food label that says carbon facts. This cheeseburger requires 243 grams of carbon. It's the transportation, it's the fossil fuel, it's the et cetera, et cetera. We don't have a food label like that, right? So agriculture, anthropogenic, so human greenhouse gas emissions are highly related to agriculture. Some say up to 30% of our GHG emissions are related to that, if you consider everything, right? So it's the crops, it's the fertilizer, the agrochemicals, the petroleum products that are used for the machinery and making all of this machinery, the transportation and the feedlots and the slaughter and the refrigeration and the market, et cetera, et cetera. It's a huge, significant number. People place that at different levels, but I've seen up to 30%, right? So agriculture definitely has an impact. Very high GHG emissions. Why don't we label it? If we replace, so the graph on the right here, if we replace beef with plants in the US per person per year, we could significantly reduce the amount of cropland we needed, right? So we could reduce our cropland by 90% if we just grew food for people instead of growing food for livestock. We could reduce our greenhouse gas emissions, some say like up to 96%. We could reduce our nitrogen fertilizer by 94%, which again is running off into our water and streams and causing the dead zone and so on. So there are just so many reasons that we should consider reducing or eliminating our meat and dairy. And indeed, there is increasing research about this. So absolute veganism, unsurprisingly, is the most environmentally friendly diet. Die-hard leaf eaters can claim to have knocked off 85% of their carbon footprint. And this graph here is from The Economist in 2019. So you see the average diet across the top, where you have that big meat, fish, dairy, eggs component, and you get over 200 CO2 carbon dioxide equivalent, kilograms carbon dioxide equivalent. And then the reduced, so it's kind of reducing your meat a little bit. Then the no dairy, if you want to do that, or the vegetarian, so that's still the dairy and the eggs, but no meat. That's kind of the third one up there. And then 2/3 vegan, I guess if you're not, I don't know, we're going all the way up. Anyway, and then the bottom one would be vegan. So just plant matter and sugars and oil. So definitely, and what do they say, 85% of your CO2e could be eliminated, really, if you went vegan. So getting back to our main theme of climate change, I think this chart really shows a lot. So in 2020, we had the hottest year on record, as we have in many of the recent years. So the line, okay, so the chart here shows the years across the bottom, 1880 all the way to 2020. And then up the side are temperature variations, but the zero is the average temperature from 1951 to 1980. So we're setting that as just kind of the average, right? 1950 to 1980, that's sort of the average, the norm, if you will, right? So anything below that, the blue, that's cooler than average. So you see in the 1880s, 1900, 1920s, all the way through up to the 40s, we're cooler than that average mean, right? We're cooler than that zero. And then we kind of pop up a little bit. We still have some blue in there. But then when you look at 1980 on, you see that we're consistently above that average. And indeed, as we get closer and closer to present, each year is giving us this hotter and hotter and hotter and higher, mean average annual temperatures. This data is based on 6,300 meteorological stations on land, in the sea, in the Arctic. And you can see that data shows that since the 1880s, the average temperature on Earth has risen by 2 degrees Fahrenheit. And you can see it really clearly on this blue to red graph. Now, some of this data comes from NASA, and so I pulled this quote from one of the main researchers on the project. The last 7 years have been the warmest 7 years on record, typifying the ongoing and dramatic warming trend. With these trends, and as human impact on the environment and on the climate increases, we have to expect that records will continue to be broken. So at our current pace of things, these red lines will just keep going up, right? So what are we doing about it? Well, we have some social actions that we're doing, right? So we have tax incentives to get an electric car. We have tax incentives to put up solar panels. That's awesome. That's great. We should do that. But we don't have tax incentives. Why don't we have tax incentives for a non-meat diet? Why don't we have tax credits for being vegan, right? Or at least subsidize these farmers who are growing vegetables, grains, beans, and legumes, and so on. But instead, we're still subsidizing this other system to make meat and dairy cheaper. So these social actions, we haven't been doing a very good job of that. Maybe in the future, that would be something great. In the meantime, what can we do to mitigate CO2 emissions? Take personal action. So choose a plant-based diet. 1 calorie of animal protein requires 11 times as much fossil fuel energy as 1 calorie of plant protein. Clearly, a way to mitigate climate change is to eat a plant-based diet. If you are not familiar with it, you might want to look at kickstart.pcrm.org. It's a free 21-day vegan Kickstart. They have all kinds of meal plans, recipes, advice from their nutritionists. There's an app. Again, it's free. I'm not selling anything. I don't get any money from it, but I was trained through PCRM, and you can sign up on your computer, on your, download the app, etc. But I highly recommend, I'm putting this out there because a lot of people ask me, oh, well, how do I even think about this? But the 21-day Kickstart is a cool way to look at it. I personally have been vegan for over 9 years, but they still have cool recipes that I look at. So again, kickstart.pcrm.org. And they have this thing called the Power Plate, where they talk about fruits, grains, veggies, and legumes. Again, if you're interested, they have a ton of information on their website, and that is just www.pcrm.org. So Physicians Committee for Responsible Medicine, that's their Power Plate. But then I like to change it up and actually say, well, the Power Plate is better for people and better for the planet when we all go plant-based, when we all try and reduce our emissions through our dietary choices. That's all I have. So I am happy to go ahead and have questions if anybody has any for me.
Okay, yes, we do. So here's the first question. Electric cars have no emissions, but how do they stack up accounting for the emissions to build, recover, and operate them?
Yeah, absolutely. Do any of you have an electric car? Because you might know more about this. I do not have an electric car. I have a super old Honda Civic, and I've always thought, it probably costs more. It's probably more energy to buy a new vehicle than to keep this 1998 Honda Civic. So I am not an expert on that. I don't know. Everything I've read, so I've read a few articles on it, obviously, and I still have, what I have read is that it is still lower in greenhouse gas emissions than right. So what you're talking about really is, there's a life cycle, right? So life cycle analysis is this cool way we can look at anything. You can look at your tennis shoes or, my phone or whatever. So all those raw materials that need to be mined or grown or whatever need to be created and then come to a factory, and then you make something and then it's shipped out, whether it's your car or your phone or your tennis shoes, and then somebody uses it. And then, well, in our society, sadly, we throw it away or we recycle a little of it. But in any case, that's the life cycle of that product. And so how many greenhouse gases are produced? What are the emissions from that life cycle of and the use of it, right? I didn't say that clearly enough. Sorry. So if you have an electric car versus a gas car, we know that the electric car is creating fewer greenhouse emissions while it's being used, but you're still producing that vehicle. And again, the batteries, I think, are a big problem right now. The creation and the recycling of batteries and so on. Technology is not all that great, but anybody else can jump in here. Like I said, this is not my area of expertise, but still, big picture, what I have read is that electric cars still, in the grand scheme of things, are better in terms of greenhouse gas emissions than fossil fuel cars. But again, not my area of expertise, sorry.
Okay, well, we have someone that did comment on that. And she said, see electrifynow.org.
Okay.
1 year keeping your fossil fuel car is more expensive than your new electric car. So apparently a site to go check is electrifynow.org.
Cool, thank you.
Okay, another question. Are you seeing any evidence that the current administration is paying more attention to the climate effects of animal ag?
Oh, this is such a great question. Thank you. Okay, so I teach climate change, the whole thing, right? The big picture. And, I don't teach a whole class just on food, although I would like to. So overall, I am absolutely thrilled with the new administration because they are embedding climate policy in almost all aspects of their other policies, right? So in economic terms, in social justice terms, in education terms, in all of these different areas, we're now seeing climate change being part of the conversation. And that's great because we need that. We need to think about it from every angle all the time, right? I haven't necessarily seen them talking too much yet about food. I know there's just this huge interest among us, right, about vegetarian and vegan diets. And it's funny, I have another whole presentation. It's really cool to look at the demographics. A lot of younger and more diverse populations are much more likely to try vegetarian and vegan diets. So as more younger people, get into the growing or cooking their own food, right? I think we're going to see more and more vegetarian trends increasing, which is cool. I haven't seen a whole lot yet in terms of policy, but I'm very hopeful given that they are addressing these environmental concerns across the board in other ways.
Okay. Was curious if you've heard of Eternity. It is a corporation based in Switzerland that measures the environmental footprint of food products for the food industry. They have a database and provide food labels for clients.
Oh,
It's called EAT, EATERNITY.org/footprint.
say it again. So here, I'll just put it up here. EAT, I love it. EAT.
ERNITY.
Oh, that's so cool. No, I don't know it. That sounds awesome. I know there are various different, there's like the various green label, eco, there are different labels like that. But that's great. That's super cool. I wish we had a better app, that kind of like that food label that I gave there as that kind of example. That why don't we know that? We have no clue about the greenhouse gas emissions on anything in our grocery cart, right? I think that would be really interesting. Cool.
So
I'm sorry. One other, tell me on that first one, what was the other, the other person said something about the electric car. What was that?
That was electric, ELECTRIFYNOW.org.
Oh, cool. Okay.
Now,
I hope can you guys still see my screen?
Yes.
yes.
Okay.
So we're going to send people copies of this presentation. And since I have brought up the chat, I think that's going to be visible to everybody.
Oh, okay. Good deal. When I teach, sometimes I can't tell if students can see the chat or not. And I know if you use a tablet, you can't see this chat with the presentation. And so I always try and inform everybody.
Well, I will save the chat to make sure.
Cool. Sounds good.
Um,
Anything else?
and there's a couple more.
Oh, okay.
I'm curious about your calculations regarding methane and ag emissions. Are you using the latest calculations which suggest methane is at least 84 times more potent than CO2?
Yeah, I debated this. I'm, I think because I'm always tired of, so I'm in the Midwest for these, so I'm in Illinois. So I've talked to, I'm going to say it in a neutral way. There are many people who are big ag people in this region, and they always think that I am overreacting about everything. And so I almost underestimate a lot of the numbers to be extraordinarily cautious. And so I was finding data. I know, I agree. I've seen that methane, the issue with methane, where did I put it? I put it on one of these slides here. Here we go, right? Yeah, 23 times. So I took a really, this article is from Godfrey from Science, the very reputable scientific journal. And so that's why I use the 23 times more potent, because yeah, I absolutely agree. I've seen it 82 times more potent, but I took a really conservative estimate. It kind of depends how you figure it. The issue with methane, right, is that it only stays in the atmosphere a very short period of time, much, much shorter than CO2. So even though it's much more potent in terms of heating it itself, if you're spewing it up there, it's not going to stay as long. Whereas CO2, where we've made this commitment, right? I mean, CO2 lasts up there for a really, really long time. And so Even now, if we stop our CO2 emissions, they're just there heating up our Earth, for a long, long time in the future. Methane, it's a much shorter lifespan, but absolutely much, much, much more potent. So yeah, I don't doubt it. There's probably other data that shows 80 times the potency. I just like to keep, 23 is bad enough, but I always like to be really careful with data and not, overdo.
Okay, another question. What countries are doing the right thing on climate change and policy?
Oh, that's a really good question. Wow, that is such a good question. I think some various countries are doing some things very well. So Denmark, I'm pretty sure, is carbon neutral. In other words, they have a lot of, especially wind power. And I'm pretty sure much of the year they produce more than they use and actually sell it back into Germany. So again, they have a fairly small population. They have a lot of wind. And so, they're doing well that way. Now, in terms of food, I'm not going to, they're way high, they do a lot of meat. Well, probably not as much beef as us, but absolutely a lot of dairy and pork and so forth. So nobody's perfect that way. I do like to talk about it, Costa Rica, actually, because they're a really cool example that in their constitution, they talk about environmental protection. Very few countries, we don't have that in our constitution, right? So it talks about, the importance of a clean, safe environment. You have to look at the exact wording, but that's in their constitution. And so they kind of, that have that overview, which is pretty cool. So those would be a couple of examples that I'm thinking of. There's probably something I'm missing here. I guess the biggest issue would really be how each country meets their commitments to the Paris Agreement. And so the Paris Agreement, we've all signed on to that. Every country, pretty much every country in the world has signed on to it. And then, these sort of benchmarks that we will all be changing behaviors to meet these benchmarks over time. And it'll be interesting to see how each country decides to do that. That's a really, really good question. I need to look that up.
So my wife just said that she's been watching on the Food Revolution Network
Summit.
Huh?
And I think she said that Lebanon has now all their hospitals are 100%.
No. There is a hospital in Beirut that is 100% plant-based nutrition at the hospital.
Wow.
Because they say it's morally improper to serve them the same kind of food that put them in the hospital in the first place.
Interesting.
Yeah.
Yeah.
And then she also said that Iceland was one of the.
No, I'm asking about Iceland.
Asking about.
How do they measure up?
That's a good question. I think, what did I read about that? So they do a lot of, obviously, geothermal energy, right? So they have a lot of geothermal energy. So they might be pretty close to carbon neutral. I think they have a lot of wind there as well, too. I would think they would be probably pretty good as well. Sorry, I don't know.
That's okay. Thank you.
Another question. Does each country set its own goals?
So it's all part of the negotiations with the UNFCCC, the climate conferences. You can look on the UN website, even if you just look up probably UN Paris Agreement, and it lists out. So we have these annual global climate meetings. We've had them forever. We only know kind of the famous ones. You might remember Copenhagen was like maybe 2010, and then Paris was 2015. And so that's the one we think about, but we actually have these annual meetings and then a few big ones where we try and have a big agreement. But it's figured based on economy and population and current emissions, and it's negotiated, right, for a week or whatever, probably months before that. So you can go on their website and look at how those levels are figured.
Okay, well, those were the questions.
Cool.
And I just want to take, oh, looks like I just got another one. Oh, thank you for a very informative talk.
You're welcome. And I stayed awake, see? It's almost my bedtime.
Well, here comes another one. No, okay, that's it. So thank you very much for
Sure.
putting on the presentation.
For driving to your office to produce a fantastic presentation.
Oh, thanks. Thanks for inviting me.